From SSN News local headquarters in Portland, Maine, this is SSN Morning News with Max Moron.
Good morning. The top story today is about a group of radical earth scientists currently challenging the plate tectonic claim made by Alfred Wegener. They even claim that the land is floating on water rather than magma. To clarify for our viewers, Alfred Wegener was a German geophysicist and meteorologist who first proposed the theory of continental drift in 1912. Our first scientist here to refute these claims, our resident archaeologist, Skizzer Dufour. So Skizzer, how do fossils support Wegener's theory?
Wegener first thought that the continents may have been conjoined when he noticed the remains of organisms across continents. The first example of this was the Mesosaurus. Its remains were found on the eastern coast of South America and the southern coast of Africa. Although it was a reptilian organism, he concluded that it could not have crossed the ocean itself, because if it had, its remains would have been more widespread. The second example of this is the Glossopteris. This was a seed-bearing tree. Its seeds could have not planted across continents because its seeds were too bulky to cross the oceans.
Wow, that was a blast from the past. Now to our chief paleoclimatologist to give us a scoop on ice, Stokely Dufour.
Paleoclimatology, the study of past climates, has revealed deep glacial grooves and debris all over the world. Most puzzlingly, in tropical climates, where glaciation is unlikely to occur because of the warm climates. This is likely caused by the land being in different positions at one point in time.
What an icebreaker indeed. Now we move to Colby, here to explain the continental puzzle.
Wegener first thought that the continents may have been joined when he noticed that the east coast of South America and the west coast of Africa fit together. He then mapped out all the modern-day coastlines into the continental puzzle. This fit together in a supercontinent called Pangaea, meaning all lands.
Wow, was that puzzling. Now to our geologist, Woody.
Rock types are also strong evidence of Wegener's continental drift theory. Rocks of corresponding ages and types have been found across continents. Also, the Appalachian Trail mountain range corresponds with the British Isles, with similar rock types and structure.
Rock-solid explanation. Wegener thought that the continental drift was caused by tidal friction from the moon. Unfortunately, he was wrong. Tidal friction of that magnitude would cause the Earth to stop rotating. Here to explain how continental drift really works, our expert, Dr. O'Houlihan.
Harry Hess proposed seafloor spreading, where the magma convection underneath the surface of the continental plates would push apart the continental crust and lithosphere, as you can see here, pushing and splitting apart into oceanic ridges.
Frederick Vine took Harry Hess's 1962 claim and proved it. He showed how magnetic bands were proof of the way the seafloor spreads. This is a divergent plate boundary. A divergent plate boundary is where the plates are moving away from each other. This is the oceanic ridge. It's where the plates split. The movement of these plates causes a rift valley. This is one example of an ocean-to-ocean convergent plate boundary. This is where the less dense tectonic plate glides over the tectonic plate of higher density. This is an example of an ocean-to-continent convergent plate boundary. In this scenario, the continent's plate stays still while the ocean plate slides underneath it. This is an example of a continent-to-continent convergent plate boundary. This is where two continental plates are converging at one point, and one is forced into the surface, creating mountains. Paleomagnetism is another proof of plate tectonics. Paleomagnetism is the study of magnetic fields and rocks and sediment in the tectonic plates. Some of the things in this field are apparent polar wandering and magnetic reversals. These are both explained by the way magnetic fields move and change. This is a transform plate boundary. The movement of this boundary is when two plates slide past each other. A result of this type of movement is a strike-slip fault. This happens along the transform fault when friction builds up and tension between the two plates, and once it is released, an earthquake is caused.
Wow, that sure was a lot of information. But plate tectonics can help us understand why some mountains form, also why some earthquakes happen, and even where and why some volcanoes form. Thank you from SSN News, and tune in next week.